Hello, I'm Emily Farran. I'm based at the UCL Institute of Education in the Psychology and Human Development Department. I'm broadly interested in spatial cognition. I can split that into two different strands. One relates to people with neurodevelopmental disorders or learning difficulties, so people with Down syndrome or ADHD. I also work with a group called Williams syndrome. And the other relates to spatial cognition in the typically developing population, and I'm interested in how it's related to maths and science ability in primary school age children. Well, I can talk about that in terms of both strands of my research. With reference to people with learning difficulties, I'm mainly interested in their ability to understand large-scale space. So that means navigating, the ability to get from A to B. And I use virtual reality to investigate this. This is important for society because if you're inefficient at navigating, then it's difficult to become independent, particularly independent of your carers or your parents. So you can imagine examples where you might need to learn the layout of your new school, you need to know which bus stop to get off your bus, you need to be able to get to work and back. And all of these, if you're not very good at doing this, it has an impact on your ability to be independent. In terms of my other strand of research, I'm interested in the relationship between spatial ability and STEM subjects, so science, technology, engineering and maths. And there's quite a lot of research out there that shows there's an association between spatial ability and these subjects. In terms of societal impact, STEM industries contribute vastly to the UK economy, but there's a real shortfall in the number of people joining STEM industries after their degree, or even choosing to do a STEM degree. So if we can improve spatial abilities in children at primary school age, this will have repercussions on their maths and science abilities, which should impact the number of people that are joining STEM industries. So I'll talk to you again about the two strands of my research. So in terms of navigation and people with learning difficulties, the best way to do it is to describe the three stages of navigation. So when you first come across a novel environment, then you learn the landmarks in that environment, so the buildings, particular beacons, for example. Then you might learn a sequence of turns so that you can take a fixed route through that environment. And then the third stage is to understand the relationship between places or landmarks within that environment. And at that stage, you've got kind of a map in your head, what we call a cognitive map. We looked at these three stages in people with Williams syndrome and people with Down syndrome. And the key findings really were that although these people are very heavily reliant on landmarks, they might not necessarily select appropriate landmarks. So they might select a landmark that is a moving landmark or something that's not particularly unique, like a street light. The other key finding that we found was that third sophisticated stage of understanding the relationship between landmarks is rarely reached by these people. This means that they're very reliant on a fixed route from A to B. So if they get lost or if their bus takes a detour, then they've been taken away from their fixed route. This means that they're dependent on other people to help them. So there's a lot of evidence out there that spatial abilities are associated with people's maths abilities. So if you're strong at spatial abilities, you're strong at maths abilities. And that goes for science as well. So people who are strong at spatial abilities are also strong on their science abilities. What's starting to come out now is that you can train spatial abilities effectively to not only improve spatial abilities, but this also has a positive impact on maths abilities. There's also some evidence, although it's mainly linked to university level students, that training spatial abilities can have a positive impact on science abilities too. So this means that the strategies that are currently used to improve maths and science abilities, i.e. looking directly at the science and the maths, might not necessarily be the optimal way of improving science and maths abilities. It might be better to look at the mechanisms, i.e. spatial cognition, that support science and maths abilities.